Okay, class, we're in lesson 1.1, rational and irrational numbers. Lesson 1.1, rational and irrational numbers. Essential question: how do you rewrite rational numbers and decimals? Take square roots and cube roots and approximate irrational numbers. How do you rewrite rational numbers and decimals? Take square roots and cube roots and approximate irrational numbers. Make sure you get the title of the lesson, the section number, and the essential question in your notes. Expression rational numbers as decimals. Expression rational numbers as decimal. A rational number is any number that can be written as a ratio in the form a over b, where a and b are integers and b is not zero. Examples of rational numbers are 6 and 0.5. 6 can be rewritten as 6 over 1. That's what they mean by a over b. 0.5 can be rewritten as 1 over 2. 0.5 is a half. So a half written as a fraction is 1 over 2. Every rational number can be written as a terminating decimal or a repeating decimal. A terminating decimal, such as 0.5, has a finite number of digits. A repeating decimal has a block of one or more digits that repeat indefinitely. Okay, let's take a look at example 1. Write each fraction as a decimal. A, 1 over 4. How do we write that as a decimal? Remember that the fraction bar means divided by. So we're saying 1 divided by 4. Divide the numerator by the denominator. So what they're saying here is the denominator goes on the outside, numerator goes on the inside. You add your decimal point and then add 0, 0. Then you ask, how many times does 4 go into 10? 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. Bring down the 0. 4 goes into 25. 5 times 4 is 20. Then you subtract. 20 minus 20 is 0. So you know your final answer is 0.25. So 1/4 is equal to 0.25. Okay, so you start off by saying 4 goes into 1. 4 can't go into 1, so you put a 0 up there. And then you add a decimal after the 1. Then you add zeros as needed. We start off with just 2. So I'll put my point that's there, bring it up here. Okay, then I say, well, how many times does 4 go into 10? 4 goes into 10 2 times. 2 times 4 is 8. So now I'm going to subtract. What's 10 minus 8? 2. Can 4 go into 2? No. So I'll bring down my 0. How many times does 4 go into 20? That's going to be 5. 5 times 4 is 20. And then like here, as we see, 20 minus 20 is going to be 0. So 20 minus 20 is 0. All right, now we're going to use the same technique on example B, 1 over 3. So 1 divided by 3, what we do is we write out 3 first, then a 1. Everybody do that. Write down 3 on the outside, 1 on the inside. Now, can 3 go into 1? The answer is no. So we put a 0 there. Okay, so we figured out that 3 can't go into 1, so we put a 0 there. Then we put our decimal point here and here. in the same spot right above it. Now we ask, how many times does 3 go into 10? How many times does 3 go into 10? 3 goes into 10 3 times. What's 3 times 3? 9. What's 10 minus 9? 1. All right, can 3 go into 1? No. So we bring down that 0. We ask the same question. How many times does 3 go into 10? It's going to be the same answer, 3. 3 times 3 is 9. 10 minus 9 is 1. We bring down another 0. And we ask the same question. How many times does 3 go into 10? 3 goes into 10 3 times. 3 times 3, 9. 10 minus 9, 1. So we end up with 0.333. So we end up with 1/3 is equal to 0.3. And we write a line over the 3, and this bar tells us that the 3 is going to be repeating. It tells us that the 3 is going to be repeating. Okay, now when converting a fraction, to a decimal, remember these steps. Divide until the remainder is 0 or until the quotient begins to repeat. Add zeros after the decimal point in the dividend as needed. When a decimal has 1 or more digits that repeat indefinitely, write the decimal with a bar over the repeating digits or digit. Okay, now we're going to express decimals as rational numbers. You can express terminating and repeating decimals as rational numbers. Example 2. Write each decimal as a fraction in simplest form. A. 0.825. The decimal 0.825 means 825 thousandths. Write this as a fraction. To write 825 thousandths, put 825 over 1,000. Now, how do we know to use the word thousandths? We have to know our places. The 8 is in the 10th spot. The 2 is in the 100th spot. And the 5 is in the 1,000th spot. Once again, 8 is in the tenths, 2 hundredths, 5 thousandths. So it's real easy to write 825 over 1,000. After doing so, we're going to simplify the fraction. All right, so then we ask ourselves, I got 825 over 1,000. What number is it, or what's the highest number or the biggest number that can go into both 825 and 1,000 evenly? And that number is going to be 25. So 825 divided by 25 will give me 33. 1,000 divided by 25 will give me 40. So 0.825 is equal to 33 over 40. Now, if you couldn't do it using 25, then you would start out small with a number such as 5. 5 goes into 825 evenly, and then 5 goes into 1,000 evenly. And then you work your way down. All right, B says 0.37 repeating. That means that 37 is repeated. So 37, 37, 37, 37. And of course, it just keeps going. All right, now this is a little different than converting a regular decimal without the bar, without the repeating bar across the top. So let's see what the instructions are. Let x equals 0.37 repeating. The number 0.37 has 2 repeating digits. So multiply each side of the equation by 100. Each space represents 10. So 10 times 10 is 100. So we got 2 repeating spaces. 1, 2. 10 times 10 is 100. So we multiply both sides. So here I get 100 times x, and here I get 100 times 0.37. Now 100 times x is just 100x. 100 times 0.37 means I move the decimal 2 places. 1, 2. So I end up with 37.37. Or now this is so because don't forget now 0.37 with the bar over it means that it's repeating. So you got 0.37, 0.37, 0.3, excuse me, you got 0.37, 37, 37. That would continue. But if you multiply this by 100, you would end up moving the decimal 2 places. 1, 2. Which means you would end up with 37.37. Of course, that's still repeating. All right. Because x is equal to 0.37 repeating, you can subtract x from one side and 0.37 repeating from the other side. So 100x is equal to 37.37 repeating. So let's subtract the x and let's subtract a negative 0.37 repeating. Excuse me, let's subtract 0.37 repeating. So 100x minus x is 99x. 37.37 repeating minus 0.37 repeating, this is gone. So you're just left with 37. Now solve the equation for x. Simplify if necessary. So I got 99 times x is equal to 37. 99 times x is equal to 37. I want to get that x by itself, so I divide both sides by 99. So 99 on this side, 99 on that side. What's 99 divided by 99? That's going to be 1. So I'm left with just 1x. And then I have 37 over 99. So that's my final answer right there, 37 over 99. Now see that says 1x, right? How many x's do you see there? 1. So you don't need to put a 1 in front of it. So just write x is equal to 37 over 99. And you got your answer. Okay, shortcut to this technique. Now this works in 99% of the cases. This works in 99% of the cases. It's real simple. Whatever number of digits you have that are repeating, put that number 9, put that number of 9s over it. For example, 0.3. So one digit is repeating. So I will write that as 3 over 9. And I have my fraction without doing all this. Of course, I reduce that to 1/3. 0.66, I write that as 66 over 99. And then I reduce that. I'm going to use 33 to reduce this. So 33 goes into 66 twice. And 33 goes into 99 3 times. So I end up with 2/3. Here, I got 3 spaces that are being repeated. So I'm going to write 576 over 999. All right, now, so I'm going to take 576 and 999. I'm going to reduce that by using 9. 576 divided by 9 will give me 64. And then 999 divided by 9 would give me 111. Now, if I were to divide out 64 divided by 111, I would come out with 0.576. If I were to divide 2 by 3, I would come out with 0.66 repeating. And if I were to divide 1 by 3, I would come out with 0.3.